Math 100, looking at lab number 25. This lab is very similar to lab 24. Normally I would combine these two, but let's look at this one. It's same idea. You've got a polynomial, and we want to talk about all the possible rational zeros for that polynomial, and then find the actual zeros of that polynomial and write it in factored form. So the first thing we want to look at is the possible rational zeros. And again, you're going to look at the numbers, the constant on the end, and the leading coefficient. Factors of 63 go on the top. That'll be 1, 3, 7, 9. Let's see. 21 goes into 63 3 times, and then 63. And then the factors of 4 are 1, 2, and 4. And then build your list from there. So you have all of the integer coefficients or integer numbers here when you divide them by 1. And then you start building your fractions, dividing by 2. Get quite an extensive list here. 63 over 2. And then again, dividing them by 4. 1/4, 3/4, 7/4, 9/4, 21/4, and 63/4. So a long list, but it still narrows our possible rational zeros to a much smaller group than if it were just every number in the universe there. So the next step would be to graph that polynomial and look at the graph to see where it's crossing the x-axis. So I've graphed that with my graphic calculator, and I'm trying to look and see where it's touching or crossing the x-axis. So I see one place that it's crossing the x-axis would be right there. 1, 2, 3, 4, 5, 6, 7. Looks to be 7 on the x-axis. And then here, it's between -1 and -2, somewhere between those two. Not sure what that number is. It's one of these fractions, though, that has to be there. So what I would then do is take the 7 and use it with synthetic division for 4, -16, 75, negative, and -63. And break this polynomial down 1 degree, and that gives it to a quadratic, which would allow me then to do some work with it, be it factoring or quadratic formula. So pull the 4 down and run through 28. 28 minus 16 would be 12. 12 times 7 is 84. It'd be 9. 9 times 7 is 63. And there's that 0 in the remainder position, which I knew that was there. That was going to help me. So that gives me the factored form x minus 7, and then 4x squared plus 12x plus 9, and as the polynomial in the factored form. And that would allow me to try the x method for factoring the quadratic here. 4 times 9 is 36. That'd be 12. That'd be 6 and 6. And so that's 4x squared plus 6x, 6x plus 9. Group those two. 2x. And I'd leave a 2x plus 3. This one would be a 3. That'd be 2x plus 3. So the factors are x minus 7. Then we have 2x plus 3 twice. And that shouldn't be a surprise, because when you have a repeated 0 or repeated x-intercept, with this one has a multiplicity of 2 because it happens twice. That's what it looks like on the graph, is it's going to bounce off the x-axis or be tangent to the x-axis would be the more mathematical term. But I like the term bouncing off the x-axis. So here we get the factored form, or you could write it this way. 2x plus 3 squared would be also a good way to write that. The zeros you're going to get x equals 7. That's the one we got from synthetic division. And then if we set 2x plus 3 equal to 0, and we're going to get x equals negative 3 over 2. And that is between negative 1 and negative 2. But this one has a multiplicity of 2 because of the squared in the factored form. That multiplicity of 2 and that squared go together. And that would be the basis for lab number 25 in Math 100.